Okay, so some of this you already know. This slide you should already know. In physical science, we talked about electron orbitals and electron arrangements. And I know it's been 2 years, but it's not something that never comes up in your life. So hopefully this is not news to you. Electrons arrange themselves at energy levels or definite distances from the nucleus. So this is one model of an atom. Our models have improved. We know now that they're not like layers of an onion, but it still helps you think about it this way. That in the first energy level, which is closest to the nucleus, there are 2 potential electrons. And if there are 2 electrons in that energy level, and that energy level is full. And in order to add more electrons to that atom, you have to stick more on the next layer. So think of an onion, right? Right in the middle, the leaves of the onion are small. And as you go out, they get bigger. And so it's the same idea for an atom. They aren't actually spheres. I'll show you better pictures in a minute, but this is kind of the scaffolding to help you think about this in the right way. The next layer out, and for several layers, we want 8 electrons, okay? Then you can have, in the third shell, although only really big atoms get there, you can have 18 electrons potentially in the third shell. And the fourth shell, only just a few atoms have. And it gets even bigger. But the concept is that as the shells get further from the nucleus, you can put more electrons there. Okay? So these shells get bigger as they go out. The total number of electrons in a neutral atom equals the total number of protons, and this is an important concept. So if you have an atom that has the atomic number 6, which is carbon, the atomic number 6 means it has 6 protons. A neutral carbon atom will also have 6 electrons. So the number of protons and the number of electrons are balanced. Protons, remember, are a positive aspect of an atom. Electrons are a negative aspect of the atom. So in order for it to be electromagnetically neutral, it has to have the same number of positives and the same number of negatives, right? The force is in balance. I'm excited about that movie. So the same number of positive and negative things makes an atom balanced. In higher energy levels that are further from the nucleus, there are more electrons. So again, if you think about layers of an onion, or if you think about orbits around the sun, however you want to picture this in your brain, whatever analogy is most helpful, the further you are from the nucleus, the further you are from the middle of the atom, the more room there is to pack things around, right? So if we could use the round table here to represent the nucleus, and I could have 2 students next to it, and in this we could fit more students, but let's say 2 are standing here, this orbit is full. But if you stood several feet back, now I can put much more people in that circle around that center thing. And further out, you can put more people in that circle around that center thing. Okay, so layers, as they get higher, you can put more in it. Does that make sense for everybody so far? This is physical science level stuff. We haven't hit chemistry yet. You okay with this idea? Okay. But now we're going to screw it all up because they're not round, right? They're not like planetary orbits, and they're not like onions. But that model helps your brain get into the concept. In each energy level, there are orbitals, and orbitals can contain 2 electrons each. And each orbital, having 2 electrons, each electron has a different spin. So I'm going to screw you up now. In the first energy level, there's only 1 orbital. It only contains 2 electrons. One of them has what we call top spin, and one has bottom spin. And that doesn't really mean anything with regard to direction. It just helps us keep them straight. And you're going to draw pictures of electron orbitals in a little bit, and you will draw with an arrow up and an arrow down, meaning There's the top spin electron and there's the bottom spin electron. So the next energy level that has 8 electrons has how many orbitals? If it contains 8 electrons, how many orbitals are there? 4. Yes. Yes, there are 4 orbitals because 4 times 2 is 8, right? And in an energy level that has 18 electrons, there would be how many orbitals? 9. Right. See how this works? If you can multiply and divide by 2, you're still in the class. Okay, this works. So energy levels are divided into orbitals of 2 electrons each. And each of those electrons, we say, has a spin, top spin and a bottom spin. So I think I get into some pictures now. Oh, no, just kidding. Almost to pictures. Almost to pictures. So level 1 has 2 electrons, 1 orbital. And we give that orbital a letter name, S. It does not actually stand for sphere, but it's helpful that level 1 is a sphere. And so you can think of 1s, energy level 1, the orbital S as a sphere, and S stands for sphere in your brain. It helps you remember that. Okay, a spherical orbit called 1s. Now, level 2 also has an S orbital, but it's just bigger. It's further out. We call it 2s. Every energy level starts with an S. Every energy level starts with an S. So there's a 1s, there's a 2s, there's a 3s, there's a 4s. They all start with an S. But energy level 2 can hold 8 electrons. So we don't just have an S, we have 3 other orbitals. Okay? So energy level 1 is a sphere close to the nucleus. Energy level 2 is bigger, it's further away from the nucleus, and it starts with a sphere, 2s. And then now we have to find out what to do with 6 more electrons, because they're not going to be in the same sphere. We have a name for them called 2p. You guys done writing this?
Yes.
Okay. But we'll get to that in a minute. So here's 1s, a ball oriented around the nucleus. The nucleus is at the origin of the system, where X, Y, and Z meet. And then there's a cloud close to the nucleus called 1s, and in there somewhere, I could find 2 electrons, one spinning one direction, one spinning the other. Okay? The next 6 electrons in the p orbital are arranged in oblong orbitals along the 3 coordinate axes. They look like Q-tips. I'll show you a picture here. So 1s is a ball. Then there's a bigger ball, 2s, which goes around it. And then at the same average distance from 2s, there's 2p, and there's 3 2p's. There's the 2p on the x-axis, there's the 2p on the y-axis, and there's the 2p on the z-axis. So we call them 2px, 2py, and 2pz. And remember, after you've had too much coffee, 2p or not 2p, that's the question. This is the joke. Okay, so 1s, 2s, and then 3 2p orbitals, 2px, 2py, 2pz. And there are 2 electrons in each. So there's a 2px top spin and a 2px bottom spin, and a 2py top spin and a 2py bottom spin, and a 2pz top spin and a 2pz bottom spin. So far we have 8 electrons in an atom, 2 in the first orbital, 8 in the second, I'm sorry, 2 in the first energy level, 8 in the second energy level. Okay? We keep going down this road. It's a beautiful road. So this is what the 2p's look like, okay? 2s would be a sphere, and it would be as big as the outside of these balloon-shaped things, or these Q-tip-shaped things. 2s is a sphere, and at the same average distance are the 2p orbitals. So there's a p orbital that goes this way, there's a p orbital that goes this way, and there's a p orbital that goes this way. P orbital x and y and z. And I'll show you a conglomerate picture of this in a little bit. It's kind of cool. Now we step into electron level 3. We get into 18 more electrons. There are 2 in the 1s, 2 in the 2s, 6 in the 2p's. Now we're in the third energy level. There are 2 electrons in 3s, because it's a sphere, just like 1s and 2s. And there are 6 more in 3p orbitals. So it's just like 2 until you get to the next group of electrons. There can be 10 more electrons in 5 what are called d orbitals. D orbitals look like double p orbitals. They look like 2 of those oblong Q-tip things crossed. I'll show you a picture in a little bit. But they're on the diagonal. Oh, it gets ugly. It gets really ugly. They're on the diagonal, so it's not on x and y and z. It's on the diagonal between x and y, or on the diagonal between x and z, or on the diagonal between y and z. And then one of them is just really funky, and I'll show you a picture of that in a little bit. That's the x squared, y squared, and both of those are subscripts of the d. Can't even make my typesetter do that. What you need to know, basically, is there are 10 more electrons in d orbitals. And then the last one, the z squared, looks like a ring and a pole. And it's so weird to think of that being one orbital. You have one electron going like in a donut around the nucleus, and the other one going straight up and down. It's a weird looking thing. There's all kinds of letters here. You feel like you're playing alphabet soup. But once you start working with it, it will take shape in your brain. I'll back up. So the d orbital that's on the diagonal between the y and the z, we call d, y, z. And you see it's not on the axis. It's like spun on the axis. We go back one. Hello? Oh, you gave up. Oh, it is still recording. That's cool. There's another one that's on the diagonal between the x and the z. So it's spun this way, and you can see it's coming out. There's one that's on the diagonal between the x and the y, and it's spun out on the diagonals. And then there's another one on the x and the y that's not spun as much. That's square on the x and the y, straight on the x and the y. So that was called xy, and then they squared, just to let you know that it's also on the xy axis. And then here's that funny one that looks like a pole and a donut. And so we have all the s's, all the p's, and now these are what the d's look like. Okay? There is one more level. There's one more level of complexity before your heads explode. Level 4 holds 32 electrons. Holds 32 electrons. 4s, 4p, and 4d gets us to the 18. The remaining are stored in what are called 4f orbitals. I am not going to make you know their orientations. The orientations are weird. So just know that there are 14 more electrons in what are called 4f orbitals. Okay, and the orientation is just bizarre. And in the chemistry that you and I will be doing in class, the 4th energy level is all that we need. There are 5 energy levels and 6 energy levels, but we won't be playing with them here. Okay, so these, this is a summary of everything we just covered. 1s, energy level 1, 1 spherical orbital. Energy 2, energy level 2 has a 2s, also has 3 2p's. Okay? Energy level 3 has an s and 3 p's, and then 4 d energy levels. And energy level 4, energy level 4 has an S and 3 P's and all the D's, and now it has the F orbitals. So each of these represents 2 electrons, which means that elements 1 and 2 only have energy level 1. Elements 3 and 4 would have 1s and 2s. Elements 5 and 6 would add this energy level. 7 and 8 would add this energy level. 9 and 10 would add this energy level. 11 and 12 would go back to another S. Okay, and you can see how this goes. 13 and 14 would add this one. 15 and 16 would add this one. 17 and 18 would add this one. You don't see this to your element 19. 19 and 20, 21, 22 as you go through. Then you've got to go all the way back through them again before you start adding F energy levels. So the elements that are down in the lower and middle part of the table, the ones that we will use mostly in chemistry, in high school chemistry, are going to have S and P and some D orbitals. You will only be drawing F orbitals maybe once or twice because just to see if you can do it, not because it's a habitual thing that you're going to do a lot of times. But you do need to know the levels, energy level 1, 2, 3, and 4. You need to associate 1 with S, 2 with P, 3 with D, and 4 with F. So S, P, D, F, if you can think of a fun little mnemonic or acronym to help you think of that. Yeah, I don't know what it is. Silly people drink Fanta, that comes to mind. I don't know. But something that helps you keep these letters in order, that will be helpful to you. Also remembering that there's only 1 orbital in an S, 3 orbitals in a P, 5 orbitals in a D, and 7 orbitals in an F will be necessary as well. I will not ask you to draw pictures of like, this is where the balloons go and this is where, no. But you do need to know the orientations as far as like what kinds of orbitals occur at which energy level and how many you can put where. Okay? And you're going to be doing a lot of practice with these concepts this week. Okay? Put it all together and what have you got? This is what an atom with some, with at least 1 set of F orbitals would look like. It looks like a carnival balloon seller at the fair or something like that. But you would see these orbitals popping out at all different angles from the nucleus. And if you were to strip it back, you would see another, layer of balloons for the energy level underneath that. And you just strip that back, another energy level, and another one inside. So it's a very complicated level or arrangement of these orbitals. And it took scientists a long time to figure this out. And people's entire careers went into that picture that you're looking at. So it's crazy how much work it took to learn, and you will get to play with it at least a bunch this week and in the next couple of weeks as we continue to go through this. So I know that that was fast and that's a lot of letters, but what questions can I